Hello everyone. Today I am talking about the binomial theorem and the associated Pascal triangle. Okay? So binomial theorem and Pascal triangle. You see, this is algebra, and you see geometry triangle. So you may have heard of the name the binomial theorem. Okay, don't be scared of theorem or whatever. Okay, it's bear with me. It should be straightforward. Okay, and I will help you to get through it. It is used extensively in mathematics. Okay, so is this identity. Okay, a plus b squared equals to a squared plus 2ab plus b squared. This is the binomial theorem, a specific case of the binomial theorem. Okay? The binomial theorem is a plus b power n. Okay, it's something. N is a natural number. Okay, this is how mathematicians want to say that n is a natural number. Okay, you can think of this like a bag. Okay, this is a bag designated by the label n, and n is here. Okay, 1 2 3 4 5 6. Of course no one do this, so they but in their mind this is a set. Okay, this is set theory. But for the moment you just think up, there is a huge bag. Okay, and you label it n, and then in that bag you put on the natural numbers. And when you want to say that n is one member of this bag, this is right. Okay, that's it. Okay, now I want to show you how to go from this identity that all of you familiar with, high schoolers, right? Maybe year 8 or year 9, I don't know, and go into this one. Okay, from here go to here. That is I want to talk about in this. Okay, now but let's start slowly. Okay, so studying mathematics should be with a very low pace. Okay, thinking, asking question, not memorizing. Okay? There's no rush. Okay? Even if you have an exam, a test in front of you, and you are still weak in mathematics, forget the test. Okay, just go to the basic and then understand it, and then you can compensate for the next test. Okay, now I want to prove this one. I know it's easy, but I want to emphasize that you understand it 100%. Okay, so first we have to understand what this means. A squared is by definition is a times a. Okay, when I write this, it means by definition. So by definition, then you don't ask. Okay, this is how we default. So a plus b squared is by definition a times b, a plus b times a plus b. Okay, now we just use the algebra rules that we know. S plus y times z is sz yz. Okay, so I do that with a a square, AB, BA, BB. And AB and BA is the same, okay? Because the position doesn't matter. There's a name for that, but I don't know. For the moment, I forget the name. Maybe what is that? Commutativity, but this doesn't matter much. So is they the same? So it's a squared plus 2ab b squared. Of course, you can write 2ba, but ab is better because in the alphabet a is before b. That's it. Okay. So we already have this one, but that's not everything about it. Okay, after you get this identity, you have to understand why is called an identity. It's called an identity because it's valid for every a and b. Okay, if you put any a and b is real number. Okay, a and b is real number. You put any a and b is always correct. Okay, I can put a is 1, b is 1, I can put a is 1, b is 0, whatever is always correct. Okay, I try with this for you to see. 1 plus 1 is 2, so this is 4, right? Here 1 square is 1, 2 ab is 1, so it's 1, and b is 1, so it's also 4. Okay, that's why it's called an identity. Okay, identity. This is not an equation. Okay, not equation. Okay, because equation is only valid for certain values. Okay, like this one. It's not an identity because it's only valid when s is plus or minus 2. Okay, I hope that you have to understand everything. Okay, and it's possible to do that if you go slowly. Don't learn for rate. Okay, learn for understanding and for the beauty of mathematics. Okay, but that's still not everything. You have to look at this and understand a squared, b squared. Okay, here you have on the right hand side you have a plus b squared. So you see the powers are the same. You see 2 here and 2 here, 2 here. But then you ask, number 2 is not important. Here a is only 1, b is only 1. Yes, it's 1, but then this is 1, this is 1. So actually this one, the power is 2. Okay, so when you expand a plus b, okay, expand, this called an expansion, right? And this is 2 terms, so that's why they call it a binomial expansion. Okay, and then every terms in this binomial expansion is of second order. Okay, or of power 2. Okay, so if you do this and then you write a b square, then the teacher look at that and then wrong. Okay, because this is a1 b2, the power here is 3 and this is 2. You see, so power 2 plus power 2 plus power 2, consistent. Okay, and that's still not everything. Why here we have this is equal to a squared plus ab plus ab plus b squared. 1 2 3 4. You have 4 terms. The question is why? Okay, because if you understand that, then if you make this mistake and then you know that you were wrong. Okay, so why? Then just go back to the the left hand side is like this. So this guy two terms, right? So here you have 1, 2, 3, 4. Yeah, can only have 4 terms. Okay, cannot have more. If you don't think like that, you can think about something like this. Easy. Okay, here you have this pair. Okay, and here you have another pair, this and this, and you want to how many pairs you can have. Okay, of course you can have this and this, that's one option. This and this, that's another option. This and that, and this and this. Okay, so I am using combinatories to explain that you should understand it. That's everything you should know about this very simple identity. It is everything what I just said. No, still not. Okay, this is going from left to right. Okay, so maybe using this one you can write 1 plus s square is 1 plus 2s plus s square, right? This is go from left to right. You have to see from right to left. Okay, this is harder. Okay, so I give you an example so that you can see that. I don't have example here, so first I go from the left to the right. Okay, 1 plus square root of 3 squared. Now I'm going from left to right. It's easy. Just this is a, this is b, so a squared is 1 to square root of 3, and then this is the 4. Okay, now this is what I want to you what I'm trying to say. You have this one, and then you have to see it as 2 plus square root of 3 square. You see, this is going from the right to the left. Okay, this is harder. So in this case you have to understand this clearly. It has to be this one, and then 1 terms here and 1 terms here. You have to write this, and then it goes to there. Okay, it's harder, but that's because if you don't get used to going from the right to the left, and then teacher can give you this problem. Evaluate this without using or simplify this radical expression, and then you stuck, even though you know this very well. Not very, you think that you know it very well, but actually you don't. Okay, so you have to see this as something squared, and if it has something squared, it has to be something plus something plus, right? Yeah, this is I want you to see, and then from that, okay, that's everything about a plus b squared, a squared plus 2ab plus b squared. I call it the formula number 1. Of course, the next step is a plus b power 3, right? If you can do this, then what should be this one? Okay, this is the questions that mathematicians will ask for themselves. Of course, they did it a long time ago, but we are rediscovering mathematics for yourself. Okay, this is active learning, you know. Okay, this is, then you have to understand first, s power 3 is by definition is s times s times s. This is coming from the volume of a cube. Okay, if this length, the size is s and s, then the space inside has a volume of s times s times s, but this is a very long, right? We need a shortcut, and then the shortcut is s power 3. So a plus b times a plus b times a plus b. Okay, now of course I can go like this, right? This one is a plus b squared, and a plus b squared I already know from formula 1, so I put this, and then I expand, blah blah blah. Of course, that's the way to go. Okay, but I stop it here, and I want you to develop the habit of guessing the result. Okay, so here is power 3. So here on the right hand side, on the expansion, I should have a power 3, b power 3. Here I have a power 2, b power 2, so it has to be. And then how many terms? Okay, so a plus b, a plus b, a plus b. So here we have 4 terms. We already do that, right? 4 terms, you make it that 1 term, 2 term, 4 term, and a plus b. And then each term here combined with this a plus b, you have 2. And then this guy give you 2, this guy give you 2, this guy gives you 2. So you have 8 terms. Okay, so you should have 8 terms. Now it's just 2, so you need system. Okay, so you need system, and all of them should have power 3, right? So you should have ab and power 3. 3 is this the only option, right? And then ab power 3 is just only 2 options, right? 1 plus 2 or 2 plus 1. 2 plus 1 here, so 1 plus 2. And now you need sys. Okay, you need sys. So here should be 3, here should be 3 because of symmetry. You see, by having that habit, or by having a deep understanding of what is going on with a binomial expansion of when n is 2, you have guessed and did it correctly. The expansion of a plus b power 3 is here. If you don't believe me, you do this tedious algebra, tedious expansion, you see it's exactly like that. Okay, so now I write everything that we have discovered here for you. Power 3, power 2, but now b is 1, power 1, but b is 2. Of course, to see the pattern, the Pascal triangle, we should write a plus b power 1, even though the expansion for this is of course a plus b, right? There's nothing there to expansion, but we have to write like that, and even we have to write a plus b power 0 is 1. Okay, anything power 0 is 1. If you write this one, and because AB can be SY, right? Can be CD, can be MN, right? This is just the names or the labels we assign to the two numbers. So what is important are not the labels a, b, but the coefficient. Okay, that's why we write the coefficient here. A is 1a, b is 1b, coefficient here, coefficient here. And if you do this, you notice that we have this 1, 1, 1. I just write down 1, 2, 1, 1, 2, 1, and 1, 3, 3, 1, 1, 3, 3, 1. And this is a triangle, right? This is a triangle. It's beautiful. So let me, I have to go in one go, otherwise it's not beautiful. Okay, this is a Pascal triangle, named after the French mathematician Blaise Pascal. Okay, in French, but it was discovered by a Chinese mathematician long before Pascal. Anyway, that's okay. So how to build this triangle? Okay, how we can construct this triangle? Because if we can construct this triangle, it means that the next row we can expand a plus b power 4 without going this tedious way. Okay, so now you see 2 is from this guy, and 3, I use another color here, 3, this guy is from this guy. You see, now it's easy. The next row is 1 here, and this guy add together, you get 4, this guy add together, you get 6, this guy add together, you get 4, and of course, this is for A4, this is a B4. Okay, so on this edge is only 1, right? Yes. So A plus B power 4 is easy. A power 4, 4A3 B, 6A2 B2, B1, and 4 A1 B3 and B4. Okay, if you don't trust me, you can do the traditional way. A plus B4 is A plus B power 2 times A plus B power 2, and this is we already know. And then you expand, and you see that is correct. Again, power 4, 3 and 1 is 4, 2 and 2 is power 4, 1 and 3 power 4 and 4, right? That's one thing. Another thing is that look at the power of 8. Okay, the powers of 8. The first term is A4, and then the second term is A3. Why? Because B is now attached to that, and then A2, because B square is now there, and then A1, because B3 is there, and then A0, because B4 is there. So here, if you look at A, the power is going down, right? By 1, starting from 4. If you look at B, the power going up, starting from 0 to 4. That's it. Okay, now I want a compact, a concise formula for A plus B power 4 using the sigma notation. Okay, I want that. This is what I want, because writing is like this is lengthy. Okay, so first I have to introduce the sigma notation. This is a sum, right? 1 plus 2 plus 3 plus 4, this is a sum, right? And mathematicians, sometimes they have to write this sum. They have to deal with this sum, plus 4 dot 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 plus 1,000 or maybe 1 million, something like this. So writing this way is not nice. So they introduce the sigma notation. Okay, sigma. When you see that, it's just the S This is s. So sum, and then you have a variable, okay, I call it I, okay, and then that variable is running from the first term to the last term, okay. So it's I equals to 1 to 4, okay. So I write slowly, sigma I equal to I start from 1 and stop at 4. It means that you give I is 1, you have 1, I is 2, you have 2, I is 3, you have 3, I 4, you have 4, and this is the sum, so you add them together. This is S. So similarly, S prime is I is equal 1, but now this is 1000. Okay, so what if I want to write this sum? Okay, the same game, sigma. Okay, now you look at a term there. A term here has the form something square. Okay, that's something you call I square, and then I is equal 1 to 100. That's it. Okay, and then if they don't want 100, they want it n squared. Okay, then is sum I equal to 1 to n. That's it. What about this sum? 1 plus 3 plus 5 plus 7. Okay, that's enough. You see what I mean. You want to write using sigma notation. How to do that? Of course, sigma. Now you have to pick a term. In all previous example, it's easy, right? The term is exactly the same I or I squared, but here 3 and 5 is different, so you have to know that there's connection between 3 and 5. Okay, they are can be raised to I, this because they are odd number, 2i plus 1. That's why you write 2i plus 1, and the starting number is 1, so I, if you want to get 1, I should be 0. That's why I is 0. If you want to get 7, I should be 3, because 2, 3, 7. So that's it. You see? Okay, I hope that is an introduction to the sigma notation. We need that because it's a convenient shortcut tool. Now going back to a plus b power 4, let's do a plus b power 3 first, okay? And then you understand a to b, a b2 and b3. Now using the sigma, you know how to do this, right? Now if you pick any term, okay, any term, maybe this term, it has the form a power something and b power something, okay, and this guy, the power, they sum up to 3, okay, and the power of a is starting from 3, so it's a 3 minus I, and b, because the sum is 3 bi, okay, and I starts from 0. I start from 0 because when I 0, the power of this guy is 3, and when the last term is b3, then I is 3. That's it. Nearly correct, okay, nearly correct, because before that we have this coefficient, okay, so here we have a coefficient that we don't know yet, okay. Of course, if you already know combinatorics, what they call combinations, right? combination C and K, then n factorial, K factorial minus factorial, then it's a different story. So maybe I assume that, and then maybe next video I talk about this. Okay, so this guy is nothing but 3i. Okay, and 3i is 3 factorial I factorial 3 minus I factorial. Okay, if I is 0, you have 3 factorial, 0 factorial, 3 minus 0 is 3 factorial, cancel, and 0 factorial is 1. You get 1. You see? 1. If I is 3, and then you had the same thing, right? 3 factorial, I is 3 factorial, 0 factorial is 1. This guy. Okay, and now I do for I is 1, and we should get 3, right? So 3 factorial, 1 factorial, 2 factorial. 1 factorial is 1. This is 3 times 2 factorial, 3. Okay. So now I will rewrite this. Copy this, paste, and I erase this one because now we know the secret. It is 3. Okay, you see that other people, they don't write that, they write n from 0 to 3, 3n, a 3 minus n, bn. It's up to them. You can use I, J, L, M, N, K, whatever for this index, okay, variable. Maybe we should use K. K is better. Why K is the best? Because we want to generalize this to a plus b power n. Okay. Now generalize to this is very easy. You just replace 3 by n. K is n, and k, a n minus k, b k, and this is a b is real number, n is natural number. So this is how they write the binomial theorem. 4ab are two real numbers, and n is a natural number. The binomial expansion a plus b power n is equal to the sum, or can be written as this. That is the binomial theorem. Okay, with this one, if you want n 20, no problem, just plug in the formula. You don't have to build the Pascal triangle rows by rows. Okay, this is 4 and 5 and 6, and go step by step to get to 20. Okay, if you want the term a10, b10, because in a plus b20 you have this term, right? You don't know this coefficient, just plug in there. Is 20 and 10. Yeah, n is 20 and you want 10, so k should be 10. That's it. It's 20 factorial, 10 factorial, 10 factorial. You can compute this. It's a big number, but you can compute it. Okay, so I hope that this video show you how to look at a mathematical formula. Okay, that is how you should look at this formula. Okay, you have to understand why the terms are like that. Okay, and then you have to see it two ways, from here to here. The forward way is easy, and the inverse way. Okay, that is how you see 4 plus 2 square root of 3 as 1 plus square root up to squared. And by having that deep understanding, you can guess, okay, you can develop an intuition about a plus b power 3. How many terms that expansion should have and what the terms look like, okay? Even before you do the calculation, that's very important. Okay, thank you and see you next time. If you like the video, please subscribe and share. And if you have any comments,